For his talk today, we will present him shortly with a cup decorated with the theme of his talk, a Penrose diagram, which I must admit I've seen just now and it looks fantastic. A black hole in a cosmological universe made by the head of the theoretical group in the mathematics department, Professor Nadav Draker. Can I invite Professor Draker to present that little present to Professor Penrose?
So you see the singularity here.
Yeah, okay, yes, I get the point. Lovely, yes.
So Roger, I'm going to put you on the spot and I want you to be as honest as you can. Does this represent anything like what you have drawn as a diagram?
What do I have to do? I mean, it's very nicely done, yes.
Nadav, I think Professor is struggling to really see the diagram he has drawn, but he's impressed.
I can see my diagram, yes, well, my eyesight is not what it used to be. But it's also just the kind of cup I like to have my coffee in. The one I've been using has a big chip in it, so that this will be a wonderful replacement. No,
Thank
this
you
is
so
great.
much.
Thank you so much. It's wonderful.
I can wrap it up.
Thank you.
Yeah, thanks. That was a really interesting and fascinating talk. My question, I was really interested in what you were presenting, your ideas, but there's a slightly different question. But what's your opinion of the many worlds interpretation of quantum mechanics?
Many worlds interpretation. No, I'm not a many worldsist, although I should say in Oxford, the philosophers are very keen on this scheme. I don't know if people are familiar with it. You see, in quantum mechanics, I did mention the issue of the collapse of the wave function, where you have a body in one of my pictures in two places at once, and we don't seem to see that. We see atoms in two places at once, but we don't seem to see macroscopic bodies in two places at once. Now, the view I hold, which I sort of hinted at, is that it's really a gravitational effect, and that you can work out, if you imagine a body in the superposition of two places at once, you do a calculation, which is roughly speaking, imagine two copies of the body on top of each other, pull them apart, and then consider only the gravitational effect, no other force. Then that is a certain energy. That energy is an energy uncertainty inherent in that superposition. And so the argument is that that superposition has a lifetime, which according to the Heisenberg time-energy uncertainty principle, that lifetime is essentially the reciprocal of that energy uncertainty. Now the trouble is that when one looks at actual superpositions in quantum mechanics, the amount of mass displacement is tiny. And so the lifetimes you're looking at are probably longer than the age, well, I can't say the age of the universe because the age from the Big Bang to now. So, a long time. So you have to get sufficiently large masses to start to see the effect. There are experiments which have been trying to look for this effect. Nothing so far has seen it. But that's consistent with how much the experiments have been able to achieve so far. I'm hoping that there will be more sophisticated experiments in the not-so-different future. We'll look to see if this gravitational collapse of the wave function, I call it, will take place. And that would say why the many worlds universe doesn't take place. The many worlds universe says all these alternatives happen at once, and for some reason which I could never quite understand, we only perceive one of them at a time. I think it means one's consciousness or something bifurcates or something. I don't quite know what it means. And that whatever conscious being you are, you're only allowed to see one of these branches. It runs into lots of troubles, but the philosophers in Oxford are used to playing with these ideas.